at prime time, live, or whenever you're watching. It's 4 o'clock at my, or it's 4:20 at my place. Or it was 4:20 when I started the stream, now it's 4:24. And thanks for live stream, we built a nice LED controller, a nice electronic product without any product managers, deadlines, or other corporate bullshit. Yes, that's correct. We are simply here to having fun, building something very nice. We are currently building an LED controller. And first tell YouTube that no, this is not made for kids. If that window were still available, but it's not, yes. But we get a new one. I make everything better with some coffee. I encourage you to take some liquid and do it too. Or beverage, I like coffee. And yes, so let's check that. Tell YouTube that it's not made for kids, and then we're going to dive right into that. No, it's not made for kids. Okay, then let's go. Oh, I didn't open the project yet. So what we are going to build is, because last time we made very good progress, and I can pull up a little bit, yes. So last time we made really good progress. So we did a complete refactor of a schematic, and we were able to move here are still one or two problems in that design. We're going to fix that. So last time we did we refactored the schematic to implement hierarchies, and with those hierarchies we can have our repetitive circuits multiple times and copy the layout completely, and that's great. And next we're going to first of all save a few things, like we don't want that. So that's connected. That's really important. That is connected. Or if you do it, you can do it at least a little bit nicer. Music is a little bit loud in my ears. And yes. And yeah, good. Now everything is set up. So next, let me get into it. Okay, let's pull all the markings at a good place. So yeah, can we get multiple markings selected? No. So let's pull all of these markings to the left, because you cannot distinguish them on the right. Let's arrange them quickly. Q5 is going to be flipped around, so we still make everything out. Q4 and that's Q3 and we're going to put R5 in between here. That's pretty obvious. Going to pull all of these a bit to the side. 28 because if they're put to the side, they don't make any problems. So, and most probably we'll set up the name. We will update the names of those wires because they're too big. Yeah, we will do this. And then down here, Let's continue here. So this can be put in here. U1, that's pretty obvious too, where this should go. Q2 can be, yeah, that needs to go down. Those need to go under the transistors, definitely. R30 is going to put all of them in the same direction. So R30 is allowed to go in here. R11 is here, R21. So R6 goes in here. R5 will be placed here, so we have so place the markings of those resistors. I will try to place them on the ground plane here. That's a C1. R21 can go here, that's not a problem. C1 goes over there, R51 goes like this. Let's do a small filling. Let's place those markings outside of the pins. Oh, okay, it's very easy. Oh yes, we placed that part to the side, so we have more space, but pretty obvious that wasn't needed much, so we will move it up further again. Yeah, that is also not critical at all. That allows us to make the ground plane a little bit bigger, which we will certainly do. And update that. Okay, I have a net clearance where I don't believe that. That looks everything good. That's all connected. That is done here. There's definitely enough clearance, so I don't have any problems with that. I'll give it some wire stitching to a ground plane later, so we can have some more heat dissipation. And heat dissipation is always a good thing. So we were doing those markings here, yes. So these are now all on one. Oh no, here's some clearance, that's not correct. Check that directly. And remove the top so we have a little bit more, so we can view thing a little bit better. And now we can do the lining of those a little bit nicer. Do it like this, and it can go like here. So now we need to somehow do these. This one can be down here because it's obvious that will be obvious that that's a cap. And we place the markings for F5, F3, F4 and L1 like so. Then it's also pretty with that arrangement it is also out of here. There's not much space for markings, unfortunately. And we still need to do them in a way so it's obvious what's what. C21 can go here. That's L1. And that's R1. It can go here. Yeah, I'm not that happy with the arrangement of the not that happy with the arrangement of all of the markings. We'll move them a little bit more and a little bit to the side, and we will give it a surrounding so it's obvious what's meant, and that's okay. Yeah, one thing about the hierarchies which is a little bit annoying is of course you get these underscores, so the part markings get really big. You check if you can get rid of them. So we put them all in one, like that. Okay, next we will edit the schematic a little bit. So those markings with the LED, so those output markings aren't that big or that long. And have them as rename. This will be V+. That's very obvious what that means. That will be a B minus, B under B minus, because later you don't see it. So later it's not really the if it's in a box or in a nice case. Nobody really notices. Nobody will notice that, so, and nobody will look at that. They will look, okay, there's RGB. I need data, and then they look into the manual. At least they should look into the manual. Or we put an extra marking on the PCB, what's what. That those outputs have a secondary function. That's okay too. We can work with that. We can work with all of that LED. Blue minus, red minus, yes. Let's arrange them a little bit nicer. Better. So save that, and let's update that. Great. Now we can move them like that in a nice 45 counterclockwise, yes. Like that. Now rotate them on 45 degrees counterclockwise. That, and also, nope. And the next one, this V+ for one, will be a little bit off center. Center. Oh, come on, that needs to be good. Okay. We are over the, yes, we are over the markings, that's great. So that's our input. Yes, for power supply by module, USB-C module that can deliver 20 volts, and then we'll feed it directly in. It's okay if it's not enough to run from USB-C. I think it's not a viable product in 2023. Can you say that? Most probably. So all the red lines that are over are for the connections to the outside. That's important. I think that's the power supply for the Raspberry Pi. Yes, it is. Okay. And we will connect this now too. Okay, I just said I just thought shit, I forgot to turn on the audio again. Okay. So let's continue. So let's do some routing and hierarchy stuff, because everybody likes that. I like that. So block 2 will unroot that one, because we did some changes to block 1. And we'll take block 1 and we'll copy placement and routing. I think that's okay. What's locked? Is L2 still locked? Oh no. Is L2 locked here too? No, it's not. Okay, let's do this again. Let's do this again. Root hierarchies. So we're under block 2, and then we will copy placement and routing, and we will copy placement and routing. Okay. Now we get that nice of oh, we also get an extra mounting hole that was not intended, but that's okay too. Let's see how good that fits. We can remove that mounting hole later, it's not a problem. Oh, it's still locked, what? Unlock. So now gently move this here to the side. And we can move it with lots of space. Yeah, we'll certainly have lots of space for everything, that's good. Next, I will check for the size of the mounting holes again. Because now it gets quite important that we have a right keep out at those mounting holes. So let's go to the browser and check everything there. Good, that's our case that we will use. Well, we hopefully put in all the holes correctly. It's always problem with the holes, I tell you. It's always problem with the holes. And the keep out, it's a diameter of 2, and it's an inner diameter of 2, and it's an outer diameter of 5. So okay, we will add those. So we will do an inner diameter of 2.3. Of course, we can do to the DIN norm, to the AN DIN isonorm, and check the according Durchgangsbohrung, the required oh, we can do that. Now come my... that's the point where my English vocabulary is off. Because now we are thinking about... now we are thinking about the... what do you call it? So I want to have Durchgangsbohrung. It's the basic amount, or it's the recommended amount of hole diameter for any given screw. And if it's a 2mm screw like M2, it would be some kind of screw that will be very similar to that. It's recommended that we use for an coarse tolerance, yeah, 2.6mm screw. Okay, that's okay. We will put that into the trace, 2.6, and that's plenty of space to correct our misalignment or a possible misalignment. And next we're going to check what kind of screw head. Like the problem is, we'll take a look on some generic screws. Like my favorite norm is the DIN 712. That are oh no, what? Photovoltaic? Am I wrong? There is also a machine norm 712. What? I need to check that. 6-Kant-Schrauben. It's in 6-Kant. So, the 912. Oh my god, that was not good. So the 912, that's my favorite norm. I'm doing so much, so little really practical in the last half year. It's not good. Okay, and but most probably we will have some kind of Linsenkopf, so round head. So we'll search for a round head. Let's take a look. Schrauben. And we want to have Linsenkopfschrauben. Yes, Linsenkopfschrauben Torx 2mm. I don't want that. Look for some 2mm heads, M2, and simply check how big the head is. Oh, we have an ISO norm here, that's okay too. And then we get a table, and then we can see that we should do at least 4mm. Or that's DK, yes. So for an 2mm screw, M2, we should use, okay, we'll use 5mm as a keep out, then we should be safe, and I think we have a space. 5mm. Nope. Oh, that's here. 2mm hole, better the coordinates, and 5mm keep out. Thank you very much. And if you have so much keep out, we can always make the hole artificially bigger. Okay, now it's... So the problem is, now we need to 9851, and that's minus 98,51. Yeah, that's certainly very eccentric, and we're going to remove the outer layer. Good. We don't need it here, very fortunately. We will need here is copy the anchor point 125.91, and we're going to add all the screws there too. So 125.91 and minus 125.91. Great, so let's copy that again. And here we have minus 98.51. And minus 98.51. Bam. And we copied it again, and that will be 142 and 98.51. Who could have imagined that? 98.51. Great. And let's do the down row again. After that, we can place the third circuit with lots of certainty, and that's always good. Placing things with lots of certainty. And due to stress, I get myself some more coffee. Man, I love this coffee. I always use the Hoffman. I use the V60 for brewing, and I always take I always use the V60 for brewing, and use the Hoffman. Okay, no, I was not complicated. Shit. 17101. No, that's not correct. What? Oh, really? 07101? Yeah, 07101. Yeah, no, it's correct. And here it's 9255, and here should be 9255 and 07101. 07101. Great. And the same thing we'll do up here too. Yeah, we now first of all need to get the right height or the right width, and then it's here, and 7101. So you can delete all of these because we don't need them anymore. Go away, and here to go away. And so now we need to think how we want to build this further, because we need to transport high currents over PCB, and that can be a problem. And we'll need to check. There can be a problem mostly with thermals, and we will evaluate in a minute what we will do. Okay, and this one here too. Okay. Great, now everything is set up properly, and we don't need this one here. And we can place the last one inside the PCB too. And it's... no, can't place it there. And it doesn't fit by... shit. And like always, it won't fit by an hair from a very intimated area by the size of that hair. That's okay. No, it really fits quite perfectly. Almost too perfectly. Oh, it really fits perfectly. I'll move that to the side. Like this. Okay. And then I will move all of them on one. What's... Why is my selection tool? Oh, yes, my selection tool. Let's see if we can move it. Nope. We will lock you. And I don't move you to anymore. And you get locked too. Can we somehow... Oh yeah, we can overlay it. And then move it to the right. Like this, great. And the same will do with this one. Oh yeah, and then we will arrange that one here. Don't want this one. Okay. And we'll see that we're already perfectly, almost perfectly arranged. Oh, and it was already locked. It was locked again. Unlock selected. We'll move this to the side. Okay, let's arrange that one by one. Oh no, it fits. Yeah, that's not good. Almost. That looks good, and now we'll slide it to the left. Yeah, that's great, cool. Now we have all the basic components on there. That's nice. Yeah, we will need to route that in a minute. But first of all, we will route that PCB. I think we have... Did we already put them onto one Flucht? Did we? The construction technique, this is upside down. No, this is not upside down. Yeah, we definitely need another board cutout here for the wires. Can be very simple. We'll forget it. Yeah, we can make it a little bit. Okay, I will pause the stream for a minute. I will be back very quick. And this time I will not forget to turn on the sound again. Yes, I will not. Okay, let's continue. Like this, or like this more. Yes. So let's continue. Yeah, this needs a cutout, definitely. Good that I thought about it. We'll simply do a okay, cut off this all the way. And we first need to do an because if we do this, we will lose the outline, so we first need to do a shape. We want to have a shape. Why can't I see my shape currently? My shape. Here are my shapes. From here, something oval. And then convert it to a board outline. Board cutout. Like this, great. So there's plenty of space to get a cable through. Because that is important if you want to use a cable. You just need to get it through. Those two will move them. Now we have the freedom to move everything a little bit more back, because we know that we have plenty and plenty and plenty of space. That makes it later easier for... it makes it later way easier to move it. Yes, then this is... We'll keep that Pico like this, because we want to put in our... Oh wait, we will move our Pico to that side, because after that we can very simply drill a hole from the side and plug an USB stick or an USB cable directly in it. That's extremely elegant, and we're going to do that. Yes, that sounds good. After that we can 3D print some small device to, or some small thing to what do you call it? A Stopfen to hide the hole. That's okay. So next, yeah, I'm currently stunned that everything did go so well. Yeah, here a small power supply, of course, for the Pico. We will add that too. So the Pico has, I think it has C10, doesn't it? The Pico has what? Control circuit. Thank you very much. The control circuit has C7, C9, C8, and C14. C7, 9, 7, 8, 9, 14. Okay. Okay, and then we have the small caps directly. Yeah, this like this arranged, yes. Let's arrange them like this. Why not? Why not arrange them like this? I mean, we can even add a smaller ground plane here for heat dissipation. That's okay. and get lots of life out of this device. Arrangement like this, that's okay. A very short one. It doesn't need to be that big, that trace, yeah. At 0.3. Okay, that is. I currently can't use my normal number keys. I only can use the number block currently. That's a little bit odd, but yeah. So, like this device will be very will be pretty much very, let's call it will be very langweilig. It will be very bored because the Pico doesn't use that much current, and I don't think we use it to the peak of its capability, so it will be most of the times extremely bored, but that's okay. That is completely okay. So may I get some arrangement, please? Okay, like that, that's great, good. Good. Now we'll place this. I think the whole power supply is in this. Yeah, it goes in here. So we'll flip it 2 times. Doesn't look right. Can we flip it completely? Like, can we rotate that? It doesn't make a big difference. Actually, it does. Yeah, we'll arrange it a little bit. Using this. I like using this. Oh. Because then I can have all of the heat dissipation in that area, and that's something I think is pretty good and I appreciate. So, this. Do this. What will do this? Okay. From here I can do ground plane. That's good. And like this and like this. Okay, good. And like this and like this. And we will arrange all the part markings accordingly. Like this. Okay. So that's of course much better. Okay, this is the output. Yes. And that's our ground, good. So we'll do first of all we'll do a smaller pour like this. We'll connect to net ground. Should have ground as a net like that. We don't. When will net 2 is it? Or I think it's net 2. Okay. Yeah. And we will make connect like this, and we will of course do spokes. One spoke. Okay. Yeah, that's good. All that can be more or less directly connected. So we'll do this 1 millimeter. No, that's too much. That will alter the pad itself, and that's something we don't want. But that's okay. That only alters the pad minimally. Oh my god, that looks odd. Looks really odd. We need to straighten that up, border. I'm currently thinking like the most higher one, like the smaller values. And that should be only 134 and only 134. Okay. Ah, almost. Straighten up something else. That's okay. Can above 150. Oh yeah, that's better. That's way better. So we'll move that to this side here. It's a power trace that's allowed to be a little bit thicker. And under this device we'll do a star grounding arrangement. So either on the top or on the bottom we will do one. No, we'll do on the bottom we will do a star ground, yes. So this goes to here. Show layer. Ah, okay. Ah, fuck, we still have music that I certainly don't have rights to. And which I'm not allowed to use. But I'm sure I'm not allowed to use it. And yes. And yeah, let's put all of them to here. So you do this although they are connected on the top side. That's actually not that needed. No, we don't do this. A Raspberry Pi Pico ground must be good enough. It's good enough. It's not decided. Connect this to here. Very thick traces, so there is actually no danger in. So there isn't actually any danger in having some etching problems because the trace is so thick. No problems, never. Okay, next. That's a power supply, yeah. And we will give it on this side. From here we will go down. So. Good, right. And from this side we will go to the how do you call it? To the complete power supply, to the connection. Okay, next. Next we will continue by adding some. Okay, what's a great question? What we will do next? Because we pretty much, and we can certainly connect these directly. Yeah. Let's connect everything to the connectors that needs to be connected directly. You can use very thin traces for that. That's not that problematic. That's not that problematic at all. Okay, let's start here. Okay, let's go here. Let's go down here and here and here. That one we will. Do we need to go to this one? No, that's not. We'll slide this one through here. And go down here. Zack. Slide this one like this. Next, we'll take a look on those connectors. That pin here. Oh, they're not aligned yet correctly. That's of course not that good. So let's continue. RV is the that are 9971. That is actually it doesn't matter that much with that kind of connector because it's not a flat flex. If it would have been a flat flex, would have taken great care that they are on the same Flucht, on the same line, but here it's not that important. It is not that important, fortunately. Okay, this one. Go up, that goes up here and down here. Oh, I don't want to go between them. So I will jump through here. When with like this, okay. That's not connected, okay. Good, continue. That's ground, okay. That's VCC. Is that VCC? Net 91. Why are they connected to the same why are they connected to the same plus 3.3 volts? Yes. Oh, okay, it's the 3.3 volts from the power from Raspberry Pi. Okay, good. Now that makes sense. But that also means that this one should be a little bit should be allowed to be a little bit thicker. Yes, that's better. Because there will be some amps that go through. Or a few more milliamps. That doesn't look good. No. Get this down here, and everything not critical, because we are away from areas where speed is really a problem, or trace length is a problem. Okay, next. Let's little veg around here, and here, and here. Let's go down, back here, down. If it would be a really high density design, you wouldn't need to think about the replacement of the connector pins way more thoroughly. But at least we're all in that area here. Okay, that fits. And let's continue here. That will be, those are not connected. Oh, that's a 3.3 volts. Yeah. That's the ground. Oh yeah, then that's the ground, okay. That's allowed to be a little bit thicker too. 08, 06. What did we do here? That was 05. Yeah, it was 05 too. That will be 05. Okay. That will be 05 and it will be connected over here. Yes. Also with 05. Okay. And we will not connect to the Pi here. Disconnect. Because, one very simple reason. Because when we force a lot of current through the Pi, because there will be a little bit more than a little, where is more connected than the LEDs. Because of that, we will need to get lots of current out of the top PCB, and that means we will go on a separate trace to ground. So we take a separate trace. That will be power. That is goes pretty directly through. Goes directly through too, and that is also power, or not connected. That is definitely power. That will be routed through the bottom directly to the to this pin, yes. Okay, great. Now everything should be routed on this side of the board. Now we can connect all of the what does that do? Oh yeah, that's way better. I want to have all of them actually. So now we need to connect all of these. Definitely by O3. And let's start connecting this one. So anyone in that area, this area, this area, this area. Great. Only the top one is a little bit off a chart. That's great to work with. Okay. Actually, there's lots of space here, so we're going to route it. Start routing everything through the top area. There will be plenty of traces where we'll need to use the bottom. And you would need to use the bottom area. Then this one too, so it's going to go a little bit up and up and up. This goes down here, and the last one goes down here too. And this one's a bit of a chart. We'll route this one later. So, what's that? That's not two, that's ground, yes. Oh no, not that we changed now all ground planes. Oh yeah, that's unfortunate, but we can still fix that. By moving it a little bit, just a little bit. Okay. Everything's still fine. Like this and the same problem here. Yes, it's the same problem here. Very fortunately, we have lots and lots and lots of space that we are allowed to use, and for that reason, let's do it like this. Great. Okay. So these are very fortunately connected in a very similar fashion too. And we can still use lots of space on the top. Which is also great. So let's use the space on the top first. And after that we can use the bottom part. Yeah, that's great. Yes, let's go down here, here, and down to here. So first of all, get this one through, because that is the next one. One nice thing that Eagle has is that you can route multiple traces at once, or that Autodesk version of PCB EDA tool, but I can't work with it. I tried once getting used to it, and it was very tedious to work, very tedious to learn, and I said no, I want something different. So it was unfortunately very EDA tools are heavily unintuitively to use. That's why I use DipTrace. DipTrace is by far not the most, let's say, powerful or thought out product, but it's extremely intuitive. And as far as I don't have any need for a much more high price, much more powerful tool, I'm certainly okay with using this one. So now it gets interesting. We can move that, we can move that. And then we are in the right place, and we can do that and move that. Yeah, these all can be moved, that's not a problem. That's not very spacey at all. Yeah, that's all great. Good. That one is off the chart again, isn't it? One is again completely off the chart. Yes, it is. And those three go to these three, and that's not a problem because we can make plenty of space here. And fiddle everything through. Yes. So, let's continue. What's the most right pin? This one is the most right. Okay. Start with that one. Go down under. And plenty. Yes, that's the most right, so you want to go place this on the right side of the track. And then almost directly connect to it. So, like this. And then you continue. That one here. Oh, that's easy too. This one was, yeah, that one is very easy too. Although we want to go more right, so we'll place this one to the top. And I will open the window, because it gets pretty bad in here. I'll get a little bit more background noise, but that's not a problem. Okay, let's continue. So we wanted to move this a little bit to the left and make space with other traces. go down under here. Oh no, I don't want to go down yet. I want to go down here. So we can go up here, connect to this place, and can create plenty of space like this. Great. And the last one will be this here. That's the last one here, isn't it? What's that? The traces, huh? Now we need to go to this one here, correct? Where's this one connected? Okay, that's ground. Didn't we just connected that one? Oh no, it's correct. That's one. Oh yeah, we were connecting 3 again. Okay. Yeah, there's plenty of space to move that. That's not a problem. And move also a bit to the bottom. There will be certainly enough space for the last one. We'll go down here, because if we go down here, we can directly go to the innermost layer, and to the innermost pin we need to go. And we see that this is very that goes very easy. Great. This and this. And we'll need to remove all the DLC errors in here, like this and like this. Great. Good. Next we'll move all of these upper pins, which go on the top side, don't we? 1, 2, 3, yes. 1, 2, and 3. Yeah, that's not a big problem too, because we can now use that area is now a little bit crowded, so we don't want to use this as much, but here is still lots of space. Lots of space that we can and we will use. So this one will go under here, because we don't want to use that precious space in between those lines yet. And we can almost go completely on the top. That's pretty great. So let's look like this. The second one, actually it's almost the same way, like we go down here through the resistors, up. Up through. And then through this keep out. And here's still lots and lots and lots of space on this PCB, which is actually very great. And then we can simply go down here, down here. Here we will go. Here we'll go underground. No. Ah, shit. Wrong. But now you can direct the stuff from here. That doesn't make a difference. And go through. Let's go like this. We don't go directly over this one because that would mean that we build an invisible wall, so we could never ever get anything else through. And go up here. Up here. And here we'll go up again, because then we don't need to put the bottom trace or bottom part for the rest. And we will simply move it very nicely through here. Good, continue here. And this one goes down there too, but we will do everything on the top part of the PCB, so everything is fine. Go down here. And down here. I don't want to have that kind of trace. Go down here, down here, down here. Down here directly to the pin. Okay. Then that's that. Okay, there are all the pins that are connected directly. That's nice. And now we'll continue adding those wires here. That is the shift register. And we can place that directly here. But it's still easy to solder from that point on. And from here all the bottom control lines will be accessed. Take myself some new coffee. And then we continue. to be connected here. I think here's not so much that we can do wrong, so oh yes, that's the that should be the clock, isn't it? Yeah. I always like to do some sanity checks if we really connect the right signals. Yeah, here we need to go down under. Go here and suck. We'll connect everything here, great. So next, that is VCC. No, that's ground. Okay, that's ground too. Then we don't want to connect it here, because if we connect the ground here, we'll have a loop which I don't want. I only want to have one ground. Okay. Good. Then we can. Although when I look at it, it is. So I'm currently thinking is yeah, we'll most probably route this through the we'll probably round the ground through L1. I think that's what Texas document, which okay, I realize. At some point I pretty much noticed if I'm 1.5 hours more or less concentrated. But I think Texas Instruments did nothing particularly different by routing the ground through the... No, they didn't run anything through the top part. Interesting. So there's nothing connected under L1, so we don't do it either. So we do some wire stitching. So we'll get a very big trace under... Not under? Yeah, we can do something under L1. Get a thick trace under L1, which will connect to the ground plane that we will produce here, yes. That sounds like a plan. Or we will keep out L1 completely, that is also an option. So that means I need to think about a way to get these signals nicely through. And for that I will certainly use this space here that I fortunately left free to get the rest of the lines through. Here's some space where we can get a few lines through, that's not a problem. Also make them a little bit, can also bring them a little bit to the side, that's not a problem at all. And voila, we have plenty of space to get control signals through. That's great. That is really great. So we have here a lot of space for control signals, and on the other side we have ground signals. Or here we share it, but you get the point. So then that's ground, that's ground, that's ground. And start with those. This one and this one. Here we can do a little bit of hopping like this, okay. Then we will have this one and this one. Where are the other two ones? These go up here and there. Okay. I will start routing those two signals. Did I forget a ground trace on? Oh yes, I forgot a ground trace. Oh, let's add this very shortly into all of them, because then we don't forget it. So that's of course very unfortunate. And the same thing here. This is like this, okay. Good. And like this. So then we have this part here, which is of. Oh yeah, that's a ground. Okay. Oh, that's a ground. That's okay. That's the ground. That is okay. And then let's continue by connecting all of these control signals. Go up here again, because here is plenty of space available. And you go through here and here. Lots of space available, very fortunately. And then connect it here. Then the next one, I will move that a little bit to the side. I can't tell you how eager I am to assemble all of that. You wouldn't know. You wouldn't know. And to find errors in the design. Oh man, I'm so eager to do it. So, and then we go here. Go through here and here, and so the next one, these two here. Here we start by not going to ground, but simply follow along here too. Okay, let's go around to keep out. Here we need to go down. Okay, like this. And let's continue. This one is left. Certainly at this. Like that. Go up here again. Tier. Down here. I just thinking about adding for at least one channel an LED array to have some sort of debugging, some sort of debug interface at least, some visual one, because we still have lots of space here. And we can certainly make lots of space free down in the bottom here. So we'll use all three LEDs for, or a free pin for a debug LED. Actually, we still have reserved connectors on here. You still have reserved pins on the connector, so we could add one direct W2, a few direct W1228B LEDs as a debug interface on the front panel and on the back panel. That sounds great, we will do this. We still have plenty of space left, but not today. Tomorrow, or maybe on Monday, but it's never on Monday. Yes, it's never on Monday. Okay, and that's it, like all the control lines are connected. I just realized there's still any... Didn't we connect it with flow? We did. Why is that red line still showing? Oh, because it's connected both to here, okay. And this is of course connected to, I was just thinking, did we forget to connect something, but fortunately that's not the case. Okay. Good. That's of course everything great. So that means next... Oh yeah, we can connect, then leave this one here too. Or is that ground or 61? That is ground, yes. So there is definitely a cap associated with this device. It is. C14, C14, C6, C9, C7. Or was it C18? Yeah, it was C14. U8 has C19. C19, okay. Where is C18? Who is the lucky one who gets C18? Could be that C18 is on the top part. C17 and C16, C15. Where is C18? Oh, C18 is on the bus 14. Okay. Even gave the Pico an extra decoupling cap. That's of course very generous of us. Yeah. And this one gets moved down here. Okay, let's take a look on the 3D render and see how it looks till now. Oh, the 3D, let's give it a go. It's just to get a grasp of the PCB until now. Wait. Oh shit. Yeah, the press is really not that eager having this big of a panel. Yeah, looks good so far. Looks good so far. Great, close it. Okay, we are not yet on the 2-hour mark, and I think I want to do 2 hours. So let's connect this further. Connect the ground here, and everything which is short to the ground by design. That doesn't look good. We will simply definitely redo this again. And also move it like this, because then it looks way better. Like this. This one also gets renewal, and that gets connected down here. Okay, now let's get a little bit cold in here. I'll close the window. Okay, let's continue. This, and then we'll remove that correct, or that to a more correct position. Okay. Let's go up here. Great. So I have all of this. Great. Then primarily what's missing is in fact only the when the ground traces are primarily missing, and that's something we don't do today. But what we can do is route this mass here. Good thing is we have our second one. Yes, we have our second one, because we need this one still as an test board, or still as a front plate, and we can use that one here as an actual that's our man. I'm tired. I am tired. I should do this now, but I don't care. So move them a little bit more to the side, so we have still the option of adding yet another W2812B LED at this point. And yeah, then we can start routing. So we can start by routing all of these. This is really straightforward. It is. Get all the LEDs connected. Of course, nobody needs so many LEDs, but it's simply nice. Very simply. So that are all the LEDs. Connect the switches. Connect all of these switches, yes. Great. Connect them from the top here too. These will connect those up here. What's the problem here? Why isn't that? Oh no, that's a diode by design, yes. That's a diode by design, yes. So, no, I don't want to route these yet. And I need to connect those. We need to be very careful here because these screws will require a keep out too. So need to be very careful there, so I won't use it so much. Okay. And when that pin gets connected to the top part. And we'll do a big we'll go around here because we don't want to limit us so much to the for routing the shift registers, because that could get very messy. That's a ground. What's C17 for? C17 is an... oh, it's a power supply decoupling cap. Okay. So it will move here. Can live here. No, we'll find a place for you. Actually, here could be pretty good. Still near enough. Yeah. Yeah. You are allowed to live here with an thicker trace. So, like this, this. Let's continue by routing those. Now this can get pretty messy because we are routing from like this and try to stay as much in the center as possible, because we'll need to get lots of these. So that's ground, and that is also ground here. So now we can get to 0.3 millimeters, and then we'll connect all of those. Let's start here. Where do we start? Where are the data lines? So let's start by fanning out as much as possible. Getting lots of traces straight out of the shift registers, so we don't start making it hard for us getting all the roots out, all the traces out. Here we can still use lots of space. Go down here, here, to here. And this one is a data pin. No, it isn't. This one isn't a data pin either. So up here we still got... ah, here it continues. Okay. U2, Q7. Oh yeah, that's an data out. But where does it go? Oh yeah, we'll move in to more to the one side, so we can simply go out from here. That's actually better. We go underneath. Can get pretty slick to the right traces. Okay, that's U2, Q4 and U2, Q4. That's J. U2, Q4 is connected to 11. Remote D12. D12, where's D12? D1, 2, 3, 5, 10, 11, 12. Down there, great. And we go through here. Plenty of space. First of all, because it is really because I don't like it that we still get those design rule checks. I will remove as the last thing I do today all of the I'll remove all of the I will convert all of the traces to silk mask, so they don't come out as a marking, but more as an elegant PCB print, and that looks a little bit better. Because I don't like it if I see red circles everywhere, unlike a YouTube thumbnail. So I will convert those real quick. And then on board that is top silk. Okay. Okay, now that looks way better. And even if we look at the render, it's okay. Please render it. Maybe we don't see it in the render, okay. Oh, we don't see it in the render. Meh. But that's okay. Good. Now we have almost reached the 2-hour marks, the 2-hour mark. And that's the point where I will turn off again and see when are we online next. Goodbye, internet.